Hello, fans of GeoGebra. We have a indeterminate problem here that my colleague said cannot be solved with Muller Breslau. So I took up the challenge and I think I solved it. What do we have here? We have an indeterminate beam which is fixed at the left and there's a roller at the right. The loading is a little unusual. It is a externally applied moment of 1 kip foot or perhaps 1 Newton meter. A unit externally applied moment. And what we're looking for is the vertical reaction here. The theoretical vertical reaction is downward. It's 3 divided by 2L. And since my L here is 10 feet or 10 meters, the right reaction is downward, 3 divided by 20 or negative 0.15. Okay, so how do we do this with Muller Breslau? So what we do is let me hide this here. What we do is we want to loft up we want to perturb the reaction that we're looking for. So you pretend that that reaction is not there and you perturb it and you watch what happens. And you pass the loads through the lofts that occur because of the delta. The loft in this case is actually the rotation at the tip because the only external load is that external moment. So if we have a measurement of that angle, we can apply the Muller-Breslau equation, R right times delta plus m external times theta, all of it equals to 0. So m external again is 1, and theta is radians here. What is the angle between the tangent at the slope of the tangent or the slope of the beam at the tip and the original horizontal? So here it is for a large displacement, and let's slide that down, slide that down, slide that down, and we get the theoretical answer here as we get this thing to be pretty small, right? So the answer is found exactly from Muller-Breslau or asymptotically from Muller-Breslau, and it requires the rotation, which is the loft, due to the delta, which is the perturbation.